All right, so now we're going to work on using some of the things we've practiced, like our factoring and looking and seeing when we're going to find a maximum or a minimum. And we're going to try to find those given an equation, okay? So the maximum is that slope again at the highest point, the tangent at the highest point. The minimum is the tangent at the lowest point. And it kind of talks about when we have these positive slopes and negative slopes, okay? So we have a positive slope, a negative slope, and a positive slope. So let's look here. So by the end of today, we're hopefully going to be able to identify the end behavior of functions and find that local mins and maximums. And then we're going to remind ourselves how we factor. All right, so derivatives. And derivatives are shown in two ways, and it looks more complicated than it is. One way that we can do derivatives is we can do this d over dx. And that's what you're going to use a lot more when you get into calculus. So you might be asking somebody about for help for derivatives, and you might see d over dx. What we usually do is we use this little prime thing here, so you can kind of see there's like an f prime right there. That's more how we're going to say the first derivative. So first derivative and then two little prime numbers is second derivative. So we do something called taking the first derivative. I think I just spelled that wrong. Let's see if I can do it better. Derivative. No, I spelled it right. All right, so first derivative and second derivative here. And then we have what's called a power rule for these polynomials. In other words, how we find the derivative. So the derivative is you take the exponent here and you bring it and you multiply it by the coefficient. So if you notice the exponent and you multiply by the coefficient and you reduce the exponent by 1. So it looks a lot harder than it is. So I think it's going to be easiest if I just show you some examples. And then hopefully you're like, oh, the theoretical was kind of hard, but the actual in practice isn't bad. What this is showing you is, okay, if you have a single term, the derivative is just the coefficient. We'll show you some examples of that. If you have a constant, and that's what the c is, the derivative of a constant is 0. Okay? Sorry about that. And so now we have first the derivative of 3 x to the second. So what you do is you actually kind of take this 2 and you bring it out in front, and you're going to multiply it by the 3, okay? And then you're going to take the 2 and you subtract 1 for the new exponent. So the answer here is 2 times 3, or 6x, now to the first. Now we usually just use leave 6x to the first as just 6x. Let's try another one. F of x is 4x to the second minus 2x plus 1. Okay, so again, we take the exponent and we multiply it by the coefficient. So we're going to take 2 times 4, and then our answer is now going to be x to the 2 minus 1. All right, so this is really going to be 8x to the first, and you're going to be able to do that kind of very quickly. Here, you really kind of have an exponent like in the last one, it's a 1 there. And so the next one is going to be 1 times that minus 2, and then we have this for our new exponent. So our answer here is a negative 2, and then it's almost like x to the 0. Well, x to the 0 is really just 1, and so we just write it there as negative 2. This derivative of a 1, remember, if a constant, is just 0. Well, we usually don't write plus 0, so we're just going to leave it like that. And actually, I'd probably have my answer like this. Okay? Let's look at 3. So 3, we're going to look at negative 2 times the 3 here. So I'm going to go negative 6, and then you reduce this by 1, so it's x squared now instead of x to the third. Next part here, we have 2 times 2, so we're going to go plus 4x to the first. Now it's like 1 times negative 18, so it's minus 18. And then this 37 we ignore, it's like a 0 because we take the first derivative of 37 and we get 0. Okay, so that's basically how you find the derivative. Now let's talk about how do you find the second derivative once you found the first derivative. So we have a nice long problem here, and it says, okay, find the first derivative. Well, the first derivative would be 20x to the fourth. So I took the 5 times the 4 and then reduced the 5 by 1. Then we would have 12x to the third. 4 times 3 is 12. Reduce that exponent by 1. Minus 24x to the first, all right, 2 times 12, plus 23. So when it's just down to an x term, it's just going to be the coefficient. And the good news is f, or the second derivative, just says, basically, you just look at the first derivative and you find the derivative of that. So now I have to take 4 times the 20 here. So I get 80x now to the third, okay? The 3 times the 12 would be, 36x, and now to the second. And then we have minus 24. So the second derivative is just taking the derivative of the first derivative. Now, let's talk about where is this used? Well, what we're going to do is we're going to be taking a function, and it's part of just finding the graph. So our first step is find the first derivative. Okay, we're getting good at this. 8x to the second minus 6. Now let's find the second derivative. Okay, 2 times 8, 16x, and then we'd say plus 0, but we're not going to put plus 0. So your next steps are these, and I know on your sheet there isn't a lot of space, so you're going to kind of have to find space, and a lot of times I'll do it like over here in the little margin. But since I want more space here, your next step is to set your first derivative equal to 0, and you're trying to solve that there, okay? 3 times 2, I just realized I made a mistake here. 3 times 2 is not 8, 3 times 2 is 6 here. And then 2 times this, sorry guys, I made a mistake, I just caught my mistake. So I should have a 6 here. There we go. Now, this is why we practiced factoring yesterday. So in order to solve this, I'm going to factor out the 6. And this is the difference of two squares. So x plus 1 and x minus 1. Now, when we're trying to say what are the top possible values of x, in other words, what makes this true? If 6 times something else equals 0, either this has to be a 0 or this has to be a 0, because that's the only way when you multiply it by the 6 you get a 0 for an answer. So what makes this equal to a 0? X plus 1 equal to 0. Well, if x is equal to a negative 1. What makes x minus 1 equal to 0? Well, if x is equal to a positive 1. So what we have to do now is we say that either x is equal to a negative 1 or a positive 1. We're also going to go here and we're going to take the the second derivative, and this has to do with our point of inflection, 12x, and we're going to set it equal to 0. Where in this case, x would have to be 0. Okay? So now we have 3 values for x, and we're going to take those values for x and we're going to find out what would they be in my original equation. So in other words, here, instead of f of x, I want to know f of negative 1. I want to know what's f of positive 1 and what is f of 0. Okay, we could do that. Of negative 1, it's like 2 times negative 1 to the third minus 6 times negative 1 plus 4. Okay? So here I'd have 2 times the negative 1 is negative 2, and this would be plus 6, so we're at 4, plus 4 would be 8. So here we had the point here, negative, let's just do it here, negative 1, 8. I'll show you why I didn't put it over here in a minute. So one of the points that we know is either going to be a min or a max is negative 1, 8. F of 1 now. Okay, let's see that one. We're going to go 2 times 1 cubed minus 6 times 1 plus 4. This would be 2, minus 6 is negative 4, positive 4. We get 0 for an answer. So our point here is 1, 0. And then the last one, f of 0, well, we're going to have 2 times 0 minus 6 times 0 plus 4. Well, we're going to get 4 there. So we have 0, 4. Okay, so that's our point of inflection. We know that's what that is. That's always a second derivative and what you get from the second derivative. And that's where we got our 0, so the 0 is what goes here. The maximum value. Well, you're looking to see where is your x the max, or your y the maximum, the highest. The maximum value is actually negative 1, 8. In other words, where's x, or excuse me, where's the y the highest? The minimum value would be at 1, 0, where we have our x is lower. And I'm going to show you with a graph here, and hopefully that'll help a little bit more. I know there's a lot of work, and unfortunately I'm realizing on this worksheet, we didn't give you a ton of space to do that. So let's look here at number 6. If I have time, I'll go back and I'll do number 5. So number 6, first we have to do what is our first derivative. So our first derivative is 3x squared minus 3. Our second derivative is 6x to the first, okay? And then our steps are take your first derivative, 3x squared minus 3, and set it equal to 0. Then factor x squared minus 1 equals 0. And then I have 3 times x plus 1, x minus 1 equals 0. So my x possibilities are either a positive 1 or a negative 1. Now, let's set the second derivative equal to 0. Well, in this case, x would equal 0. All right, so what we have to do is we have to find f of 1. We have to find f of negative 1. And we're going to want to find f of 0 for our point of inflection, because that's the one that came from our second derivative. Our second derivative gives us a point of inflection. So now, f of 1. All right, so in my head, so many times you could do this in mental math. If not, go ahead and just work it out. 1 minus 3 is negative 2, plus 2, I got 0. So this represents when x is 1, the y is 0. So it represents the point 1, 0. All right? Then we have this. We have negative 1. Well, negative 1 cubed minus 3 times negative 1 plus 2. This would be negative 1 plus 3, which would be 2. Plus 2 is 4 I got here. Okay? And then f of 0 would be basically 0. And then plus a negative 3. It's another 0. And then plus 2. So we get 2. So this was the point negative 1, 4. This is the point 0, 2. And we know that that's going to be our inflection, our point of inflection. So what does that mean? Well, how do we know which one is the max and which one is the min of these? Well, if we graphed them, 1, 0 would be right here. Negative 1, negative 1, 4 would be right here. Which one looks like the max? I'm thinking this one looks like the max because it's definitely higher on the graph, which means this one would have to be my min. So then we can just write those in. That would be my min, and again, whichever y is lowest is going to be your min, whichever y is highest is going to be your max, and your point of inflection should be halfway in between it. Now, just to make it easier, there's times like this y-intercept is easy to find because you can kind of ignore your x's and it's always just the constant. And so it's a quick one to always look, and it kind of helps you to know sometimes where your graph is. So we knew this was our minimum. We knew our point of inflection is here. And we knew this is our maximum. What does that mean? Well, minimum means that this is the lowest it gets in that little area, and then it must go up. Maximum is this is the highest it gets in that little area, and then it goes down. So those 3 points were critical in kind of knowing how this graph looked, okay? And so they were really helpful to know, oh, okay, I can kind of know how to graph my equation. Let me do another one for us as quick as I can because I'm going to run out of time. This would be, I'm going to pause it here, and you're going to see these magically appear. Okay, so what I did is I found the first derivative and I set it equal to 0. I factored out the 3, and now I need to factor and say what two numbers multiply to get 3, but when I add them I get a negative 4. So it turned out to be a negative 1 and a negative 3. So my x values could be a 1 or a 3. Then I'd have to say, okay, for my second derivative, set that equal to 0. 6x would equal 12, and x would equal 2. So I need to find f of 1. I need to find f of 3, and I need to find f of 2. So I found my 3 points now, f of 1, f of 3, f of 2. Well, f of 1 is here at 1, 0. F of 2 is at 1, 2, 3, 1, 2, 3, 4. Oh, okay, I can kind of tell that's going to be a minimum. And then we had f of 2, negative 2. That's our point of inflection. So 2, negative 2, and this maximum would be at the 1, 0. That's our highest y, and this would be 3, negative 4. That's our lowest point. The y-intercept is always going to be what happens if you put in 0 for x, and it's always going to be, again, this constant. So I know at 0, I'm at 1, 2, 3, 4. And boy, that does help me to kind of know how my curve is going to look. So I'm kind of going like this, and like that. So it kind of shows how the curve kind of evolves. Good luck and wait for the next video.